Okay, continuing here in my videos, we're going to talk about the quotient rule for finding the derivative of a quotient. Now, the derivative of a quotient can be written as, if you want to take the derivative of a function f of x divided by another function g of x, then this one's a little more complicated than the product rule. So this would be the g of x function times the derivative of f function, and then minus the f function, f of x, times the derivative of the g function, so times g prime of x. And then don't forget that at the end you actually always divide this by the g of x function squared. Okay, so another way to think of this is it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So if you like thinking in terms of top and bottom, then you can think like that. Now again, the shorthand notation, if I just assume that u is a function of x and v is another function of x, then I can think of this as v u prime minus u v prime all over v squared. So let's go ahead and apply some examples to this. So here I have the quotient where the numerator is 1 minus 3x and the denominator is 2x minus 5. Well, since the numerator is 1 minus 3x, that would be the u, and since the denominator is 2x minus 5, that would be the v. So when I apply this formula for the derivative of u over v, I'm going to have v, which is 2x minus 5, then times the derivative of u, that's my u prime, so the derivative of the numerator, 1 minus 3x, and again this is my fixing to notion, I'm fixing to take the derivative, and then minus, I kind of covered up that minus sign, that's important, so then it's minus, not plus. So it's minus u, which is 1 minus 3x from the numerator, and then times the derivative of the v term, which is 2x minus 5. And then on the bottom, I have 2x minus 5 quantity squared. Now this notation here doesn't actually go in the problem. I'm just showing you that that is v squared. Okay? So I have v times u prime minus u times v prime. And now in the next step, I'm going to go ahead and calculate these two derivatives here that I didn't do in the first step. So the derivative of 1 minus 3x, that's minus 3. And then the derivative of 2x minus 5, that's 2. So I put those in their appropriate spots. And then the next step, and then don't forget it's divided by 2x minus 5 quantity squared. And then the last step here, or next to the last step, is to distribute the minus 3 through. And when you distribute the minus 3 here, you get minus 6x plus 15. So that's these two terms. And then here, distribute the 2 through, and you have 2 minus 6x. So that's these terms. Now remember, you can really mess the sign up here if you're not careful. So that's why I went ahead and kept the minus here and only distributed the 2 through here. Now the next step would be to distribute the minus through. And so you'll get 15 minus 2, which is 13. But then you'll get minus 6x plus 6x, which cancels. So you'll just get 13 in the numerator. And then don't forget your denominator has 2x minus 5 quantity squared. And so that's the derivative of that quotient function. So this next example here, I have sine x divided by x squared. So the u function would simply be the sine x, and the v would be x squared. So going back to my formula, I'm going to take v, which is x squared. Now here I'll just go ahead and do the derivatives in my head. So I have v, which is x squared, and then I take the derivative of u, and so the derivative of u, the derivative of sine x, would be cosine x. And then I have minus u, which is sine x, and then I multiply by the derivative of v, and the derivative of x squared is 2x. And then I put that all over x squared squared. That's the v squared. So x squared squared would give me, that would give me x to the fourth. Not sure why I didn't write it there, but I did write it in this step. So x squared squared would be x to the fourth. Now in the numerator, I'm going to have just x squared times cosine x and minus 2x sine x. And then what I did here, I saw that I could factor an x out of these two terms, so I went ahead and factored an x out of each term. And when I factored the x out, I got x times x cosine x minus 2 sine x. And then I can actually cancel this x. This x will actually cancel into x to the fourth and give me x cubed in the denominator. So I end up with x cosine x minus 2 sine x all over x cubed for my final answer. Now this function here is written as a function of t, and so I'm going to let u be the numerator and v be the denominator. And so using the quotient rule, I'll have v, which is 1 minus 2t, times u prime, and so u prime would just be the derivative of this term, so, this factor, so that would just be 2t minus 5, and then minus v, which is, let's see, it goes v u prime, right? So it's minus u, right, times v prime. So this would be u, which is t squared minus 5t, and then times the derivative of, the derivative of v, right? So it's u times v prime. So the derivative of v would be minus 2. And then all over v squared. So this is the v, and I'd have that quantity squared. Now all I did here was I just FOILed this, and then over here I distributed, and you kind of have to be careful here. I did 2 steps, so I multiplied by minus 2 here, and I got minus 2t squared, but then you multiply that by negative here, and you get plus 2t squared, and then minus 2 times minus 5t is plus 10t, and then you distribute this negative, and you get minus 10t. And then if you collect the like terms, you get minus 2t squared plus 2t minus 5 all over 1 minus t quantity squared. Now this one's not too bad on applying the derivative, but when you try to simplify it's where it gets nasty. First thing I want to do is I want to write this cube root of x as x to the 1/3, because I can take the derivative of it, x to the 1/3, like that. Now, so my u would be x to the 1/3, and my v would be x squared plus 1. Now in my formula here, I have v, which is x squared plus 1, times the derivative of x to the 1/3. Okay, and then minus x to the 1/3, that's my u, times the derivative of v, which would be the derivative of x squared plus 1. And then for my v squared, I'll have x squared plus 1 quantity squared. Well, let's go ahead and do the derivatives here, because here I just showed that I was going to take the derivative, so I'm actually going to take the derivative down here. The derivative of x to the 1/3 is actually 1/3 x to the negative 2/3 using the power rule. And then the derivative of x squared plus 1 would simply be 2x. So the derivative of x squared plus 1 is just 2x. Now, so I have x squared plus 1 times 1/3 x to the negative 2/3 minus x to the 1/3 2x all over x squared plus 1 quantity squared. Now you might get away with leaving it in this form, but one trick that you can do is you can factor 1/3 x to the negative 2/3 out of the numerator. So I can just factor this expression out of both terms in the numerator. Now factoring out the first term, that's the easy part. If you factor this out of the first term, you're just going to get this x squared plus 1. So there it is, x squared plus 1. The tricky part is when you factor it out of here. Because when you factor out of here, what you're doing is you're dividing this by this expression. So to get the result in here, you actually divide x to the 1/3 by x to the negative 2/3. Well, if you divide x to the 1/3 by x to the negative 2/3, that's the same as multiplying x to the 1/3 times x to the 2/3, and x to the 1/3 times x to the 2/3 is x to the 3/3, which is x. So I have x right there. And so that's where the x came from. And now when you divide by 1/3, that's the same as multiplying by 3. So that's where the 3 came from. And then the 2x was already there. So now I have x squared plus 1, and since this is minus 6x squared, then x squared minus 6x squared is minus 5x squared, so I'll just have 1 minus 5x squared in the numerator. And then in the denominator, I'm going to have the 3. The 3 is going to be down there. And then the x to the negative 2/3, I can move it to the denominator if I change it to positive 2/3. And then I already had the x squared plus 1 quantity squared in there. Now again, the reason we might want to write it this way is so that we could set it equal to 0 and find the values that make the derivative equal 0. Okay, so again, that's just some nasty algebra there, factoring this expression from the numerator. And that's pretty much it on the quotient rule. So in the next video, I'll talk about the chain rule, which also brings in what's called the general power rule.